Today we are going to learn about the partition chromatography. In the previous class we have seen about the adsorption chromatography. And with respect to that, here also we will be seeing about the methodology, advantage, disadvantage and application of partition chromatography. What is the basic difference between adsorption and partition chromatography is the content of a stationary phase. The stationary phase in adsorption chromatography was solid, whereas in partition chromatography it will be liquid. So this is the basic difference between the partition chromatography and adsorption chromatography. So look here, the partition chromatography, basically the separation happen between the two liquids. The separation of compound between the two liquid phases with original solvent and the film of a solvent used in the column. The separation theory was introduced in the year 1940s, which was published by Richard Lawrence Wellington series and Archer Martin. It is also known as liquid-liquid chromatography. Basically, when you look into the liquid chromatography, the stationary phase is contained within a solid substance. Like in a paper chromatography, the stationary phase is water and which is present in a cellulose fiber of the paper. So with this respect, the principle for this stand like this: the separation of component from the sample mixture is carried out by process of pardoning the components between two phases. Both phases in liquid form. In this process, the immiscible solid surface coated with the liquid surface on the stationary phase is in the mobile phase. The liquid surface is immobilized by stationary phase, which result in making it as a stationary phase. The separation depend on different partition coefficient. And look at here, we have an example. We have shown it here. The how does the paper chromatography is carried out. If we look at here, it is similar to TLC, right? But the principle differs. In the TLC, the principle was adsorption chromatography, whereas in paper the principle is partition chromatography. If we look into the content, right, how it has been processed for doing a paper chromatography, basically a partition chromatography or a liquid chromatography. What we do here, we take a paper and there is a much quality. There are different quality of papers and the content are different for the mobile phase, right? I mean, it varies. The quality of paper also varies. We will see in the coming chapter, paper chromatography, how is the how differ the paper is in that. With that aspect, what we do it here, we take a paper and on that we spot the sample. Like how do we spot into the TLC? So when we spot the sample onto the paper chromatography, what we see is we have to take care for the baseline, right? I mean, how we did in TLC, it should be above the solvent system, and then you spot your sample. When you spot your sample, make sure that not too much of sample is spotted, and then give a sufficient space from both the side so that the spotted sample doesn't go beyond the paper and it goes back into the mobile phase. So with that aspect, we have to take this the jar in which you are carrying out the separation. It should be covered and equilibrium must be attended, and then you have to make sure that till what time, till what place the solvent has to run. So I mean, generally it is taken as two-third, I have said it, but sufficiently sometime you can see it by when you have a color some substance is quite sufficient separations happened. Or otherwise, where it is uncolorful compound or it is non-colorless compound, what you have to do is you have to run it till the two-third of the paper or slightly more also. Sometimes depends that the solvent is not running out of the paper. So this all is the precaution you have to take when you are handling with the paper chromatography. So this is a apparatus or procedure. How do we carry out the partition chromatography? So what is a apparatus required here? You need to have a chromatography jar, liquid impregnated paper act as a stationary phase in which the water is present, capillary tube to apply the sample mixture. Mobile phase, you have to design the mobile phase depending upon the nature of your compound to be separated. Generally the mobile phase used is chloroform, methanol, acetone, ethanol, or it may be a mixture of these two or these three, or different in different proportion. These are the solvent which are used to make the mobile phase, but not exactly the same in a pure form or in a single system. I mean, in a single solvent system, you may have a varying solvent system, and the solvent system is basically looked with the possibility of their partition coefficient, uh, or that's called polarity. So what we do it here, we take a clean and dry chromatography jar, add the mobile phase to the jar, close the lid and allow it to attain equilibrium. Apply the sample with the help of capillary and dry the sample spot. Similarly, if you don't dry, what happen is there is a chance that the sample may get back with the solvent into the mobile phase, and you may lose out the content of your sample which is already have placed is very small. So this is the procedure how do we carry out. And then what we do is, after spotting the spot onto the paper or the sample onto the paper, we place the paper in the jar and close it and allow the system to stand till the solvent move to some distance from the baseline. And this generally the movement is till two-thirds of the paper or slightly more or less than that, right? You can be very watchful when you have a color compound, you can see the separation, whereas in colorless compound it is quite difficult. So what we do, we generally mark the distance till what it has to travel. And then what we do, we take, after the sufficient run of the solvent, we take out the paper and dry it. And if the sample component are separated showing color, then ordinary light is quite enough to judge compound, or you can find out that separation has happened. If it is colorless component, then you need to treat the paper in a different form. You need to see that the spot in the UV lamp, or you can even sometime treat it with the some reagents, I mean, specific reagents are there which we will see in the coming chapter. So this is how you separate out the compound, right? I mean, and you distinguish the, or you recognize the compound which has separated. After the separation has happened, what we do is, we place it in the oven to dry, or we treat in a different method. How the procedure is done for individual component, there is a different method to treat it with the, when you have a tannins, when you have alkaloids, when you have a peptides, or when you have a carbohydrate, there is a different method. So what for it is used, right? The paper chromatography has got a the paper chromatography has got a lot vast application, right? It is used to separate and identify amino acids, it is used to separate and identify tannins, and to identify alkaloids. And then sometime it is some where it has got even importance in carbohydrate, along with glycosides, peptides, phenol, insecticides are removed, right? So these are the application of paper chromatography. What are the advantage, why do we go for partition coefficient? The biggest advantage is that it's easy to operate and economical method, right? It isolates both organic and inorganic components, saves times because it happens in short duration, right? When the polarity of solvent is slightly sometime low, it takes a lot of time to run. In spite it, that's a lot of time doesn't mean that it take too much time, right? It happens in an hour or so on, right? And it also depends upon how is the length of the paper, right? If the length of the paper is small, or the distance what you have kept for running the TLC, I mean the paper chromatography is short, it will be in small span of time it will be over, right? It provide high efficiency, right? Reliability of result is very good, so it provides accurate result. And the selectivity in partition coefficient is also better, right? You have a lot of method to choose the paper, right? I mean the stationary phase, that there are different treated papers are present, and on which you choose the stationary phase as a paper in which the water is integrated for acting as a stationary phase. So I will see the different type of paper when we see individually the paper chromatography, that how is the paper differ, right? So these are the advantage of the partition coefficient. So when we look into the disadvantage, the biggest disadvantage is that you require high volume of mobile phase and is sometimes required for separation, right? When you have a lot of sample to be separated, right? Data cannot be stored in long certain type of partition coefficient, because when sometime treatment happen or it is on a paper, the storing is a big challenge, right? And then even in automation, right, we have an HPTLC automation has happened where the whole sort of sample is plotted individually, and then you can measure out which is the sample, how much is the sample. And HPTLC cost is enormous. So the automation when has been done for paper chromatography, it is more difficult and it is costly. In gas chromatography, only volatile compound can be separated, right? In gas liquid chromatography. So this is one of the biggest challenge when you are handling the sample in gas chromatography, because non-volatile has to be turned up in volatile, and then you have to separation. If it is not possible, the possibility of getting separated in gas liquid chromatography, the sample is very difficult. It is possible to separate only soluble analyte of a sample mixture, right? Because you have when you are spotting the sample onto the paper, it must be in a dissolved form, or it must be in a liquid form, so that it can be spotted with TLC. If it's not possible, it is very difficult to separate the compound. So with this we have seen the advantage, disadvantage, procedure of partition coefficient, and we will be learning about the individual chapter paper chromatography, that how does the partition coefficient has got a beneficial uses. Much beyond this we will see in the chapter. Till then, solve the question of this section, and you can the note is attached to that, you can read that, and I mean, in discussion form you can write about the any sort of problem. So thank you.